We're going to learn about how to solve quadratic equations using square roots. So far, we've done it by factoring, we've done it by graphing and looking for some x-intercepts, and here's how we can use square roots. Quadratic equations in standard form look like ax squared plus bx plus c. But when b is equal to 0, the equation becomes much simpler to solve. It becomes solvable using square roots. All right? So to solve such an equation, the main thing you have to do is we have to isolate x squared. X squared needs to be all by itself on one side. And then we would take the square root of both sides of the equation, and we would not forget something very special. We wouldn't forget these plus or minus signs, which we're going to discuss in a second. In fact, these are so important that if you forget them, you actually haven't solved it correctly. Now, just as we saw with graphing, it is possible to get 2, 1, or 0, no solutions. So we're going to just try a boring problem that you will know the answer to right off the bat, which is x squared minus 25 equals 0. Now, before we actually get started, I think a lot of you can see the answer. You can say, oh, well, 25 minus 25 is 0, so x could be 5, which is totally true. But we're going to add 25 to both sides so we can isolate the x squared, and we're going to get x squared equals 25. And I think a lot of you already know, oh, well, I could just take a square root. But the most important thing to do is we need to put this plus or minus in there. And so that x is going to actually equal plus or minus 5. And just bear with me for a second. You don't have to copy this down. But x squared minus 25 equals 0 factors like this because it is a difference of 2 squares. So you would get x equals negative 5 and x equals regular 5. You do get both answers. And if you graphed it, you would also find that as a parabola, this one is going to cross the x-axis twice. So when we solve it algebraically, we need to account for that answer. So the plus or minus is super important. So here we have 2 solutions. Now if we try example 2, which I've sort of squashed my amount of room, let's try x squared plus 5 is equal to 5. Now just as we said before, you have to isolate the x squared. So we're going to get this x squared all by itself by subtracting 5 from both sides. And we're going to get that x squared equals 0. Well, what times what, or what times itself, is equal to 0? I think you already know the answer to that. But let's take the square root of both sides, and we're going to put our plus or minus in, and we're going to get that x equals plus or minus 0. Well, 0 isn't positive or negative, so we can cross these out. And x is just equal to 0. And we have one solution. So our final example will be, well, what happens when there's no solution, when it doesn't cross the x-axis at all? And so we're going to get x squared plus 64 is equal to 0. Now bear with me. This is actually in vertex form. Again, you do not need to write this. This is x not moving sideways at all, but moving up 64. And since it's positive out front, this means this whole thing has scooched up 64 spots and opens up. So you can see that it has no x-intercepts at all. So we're going to prove it by showing we can't actually get an answer. We're going to subtract 64 from both sides, and we're going to get x squared equals 64. Whoops, negative 64. And when we go to take this square root, plus or minus outside, you're going to get x squared equals the square root of negative 64. There is nothing that we can multiply by itself that will get us a negative answer, so this has no real solution. We say no real solution because it does have an imaginary solution. We just can't fit it on the number line, so no real solution is how you would write that. Okay, now let's try some fancier problems. Like we said before, step 1 is isolate the x squared. So in this first one, I'm just going to add 60 to both sides. And we're going to get 12x squared is equal to 60. Now, we're going to divide both sides by 12. And when we do that, we get x squared equals 5. And we need to not panic. We're going to go about our usual business of taking the square root of both sides, putting our plus and minus out front. And x is just going to equal plus or minus the square root of 5. That's totally okay. That's like 2 point something. It's a little bit bigger than the square root of 4. So don't have a problem if you get an irrational answer. It is okay. You just leave it in radical form. Do not write it as a decimal unless they ask you to. Now, this next example, what happens if you get a fraction? Also, don't panic. So we're going to add 49, we're going to add 49, and I'm going to get 4x squared is equal to 49. And now I'm going to divide both sides by 4, but I'm not actually going to divide by 4. I see so many of you like actually doing this like old school long division for like something that is not going to work out. They're both perfect squares. Leave them alone. Let's take the square root of both sides. And don't forget your plus or minus. And now square root of x squared is just x. And just take it piece by piece. This is the same thing as the square root of 49 over the square root of 4. So I'm going to get 7 on the top and I'm going to get 2 on the bottom. Do not let them migrate to the other part of the fraction. Keep the denominator in the denominator and the numerator in the numerator. And finally, for the problem that I think a lot of people really weren't sure how to do, instead of isolating the x squared, we're going to isolate this entire parentheses. We're going to isolate the entire thing that's squared. Since both of these numbers are perfect squares, I'm going to just take the square root of both sides. And I'm going to say the square root of x plus 2 squared, and I'm going to say the square root of 196. And I'm going to put my plus or minus on the actual number. So, just so you see how this plays out, you don't have to write this part down. X plus 2 times x plus 2 is x plus 2 squared. And we have a pair of the same thing, so they get to come out. So we're going to just write it as x plus 2. So now that you've freed what's under the radical, you get x plus 2 equals plus or minus 14. Now this is where it gets a little bit hairier. To get x all alone now, I am going to subtract 2. Now, most mathematics books and mathematicians will put the 2 in front like this, minus 2 plus or minus 14. But I don't have any problem with you writing it behind the 14. But we have 2 answers here. So we're going to get that x is equal to negative 2 plus 14, and x is also equal to negative 2 minus 14. You're doing both solutions. So we're going to get x is equal to 12 and x is equal to negative 16. And in fact, if you plug these both in, you are going to get that you're either squaring 14 or you're squaring negative 14. So you're going to get the answer to be 196. Sorry for the length of this video, but now why don't you guys try these 9 problems and submit this to Schoology.